Hello, dear members. Now, in this lecture, we are going to discuss the 1/3 and 3 out of 8 rules of Simpson to evaluate an integral sin x out of x from 0 to pi with 7 ordinates. Let's right away start and answer this problem. Now, first of all, we need to understand if we have 7 ordinates, how many subintervals. So if we have n ordinates, then we have n minus 1 subintervals. Now, what does that mean? This problem is going to have 7 minus 1 equal to 6 subintervals. And what is going to be the width of each interval? So the width is equal to h, which is b minus a out of n, whereby uh, n is referring to the number of subintervals. So if we are referring to n being the number of ordinates, then it will be b minus a out of n minus 1. So for consistency, let's maintain it at that level. And so this is going to be b minus a. So this is going to be pi minus 0 divided by 6. And the width of each subinterval is going to be pi out of 6. So if we start from 0, this is going to be pi out of 6. This is going to be 2 pi out of 6. This is going to be 3 pi out of 6. This is going to be 4 pi out of 6, 5 pi out of 6, and finally we shall come to pi. So what are the values of f of x? So substitute in f of x. F of x is sine of x out of x. So put in 0, sine 0 out of that. Obviously, what is it going to be? So if you put in 0, what is this value going to be? So if I put in my value at x is equal to 0, I'm going to get 1. So we have to understand how we get 1. So limit, we are going to say limit as x tends to 0, sine of x out of x tends to 1. Okay? So when you look at this, you'll find that obviously the sign of this, okay, we are saying if this is tending to 0, it means it is reducing to a very small value. If we also substitute in here, we'll find that our sign of this value is going to be reducing to 0. I mean, it's going to be reducing the same quantity, and therefore we will find that that same quantity divided by x, divided by that, you will return to 1. In other words, you know that if you took, for example, sine of 0.001, so obviously it is going to remain around 0.001. So now, if you divide it by 0.0001, it is still going to give you that 1. So as x tends to 0, sine of x divided by x tends to 1. So this is the limiting value. This limit function or limit operation is going to give us the value of this function here. So let's substitute in now for pi out of 6 is going to give us 0.9549. Then this is going to give us 0.8269. This is going to give us 0.6366. And this value, when I put in my calculator, is giving me 0.4134. And this is giving me 0.1909. And this is giving me 0. So we proceed and apply Simpson's third rule. So Simpson's third rule says that if I'm integrating this sine of x out of x with respect to x beginning from 0 to pi, it will approximate to uh, a third, okay, a third of h. So a third of h into y naught plus yn, okay, plus, now we are going to apply the values of y that in which the indexes or in which the indices are odd. So if they are odd, we are going to be having we are going to multiply them by 4. So 4 into y1 plus y3 plus y5 up to plus yn minus 1. Then plus 2 for now the indices that are even. So we will multiply by 2, 2 into y 2 plus y4 plus dash dash plus yn minus 2. That is how we get the integral using Simpson's third rule. But when we go back up here, we can determine what is y naught, what is y1, y2, y3, y4, this is y5, and this is y6. So this approximates to h. We already know it as pi out of 6, so times a third into, so the y naught, we said it is 1, then yn, which is y6, so this is y6, and this is going to be 0. So we add 4 into y1 is 0.9549 plus, okay, y3 which is 0.6366 plus 0. Which is y5 is 0.1909, then plus 2 into y2 which is 0.8266, I mean 69, okay, plus y4 which is 0.4134, okay, we close that. So this is approximately pi out of 18 into 10.6102, and this is approximately equal to 1.8518, and this is giving us the value to 4 decimal places. Therefore, we can conclude that the integral from 0 to pi for sine x out of x with respect to x is approximately equal to 1.8518 to 4 decimal places. So let's look at Simpson's 3 out of 8 rule. So Simpson's 3 out of 8 rule says that if we are integrating from 0 to pi of sine of x out of x with respect to x, this approximates 3 out of 8 of h into y naught plus yn, okay, plus 3 into, okay, this is going to be so this is y1 plus y2 plus y4 plus dash dash up to plus yn minus 1, then plus 2 into y3 plus y6, okay, or if it is a general one, then it will be plus dash dash up to yn minus 3, okay. So that's it. Now, integral from 0 to pi of sine of x out of x with respect to x will approximate 3 out of 8 times h, which is pi out of 6. And when we evaluate that, this is going to be y naught is known as 1 plus, this is y6, which is 0, so plus 3 into y1 is 0.9549 plus y2, which is 0.8269 plus 0.4134, and what else apart from y3? So we shall have also y5, which is 0.1909. Then we add twice of 0.6366. So when we evaluate that, it becomes pi 0 from 0 to pi sine of x out of x with respect to x approximates to, we shall have 3 pi out of 48 into 9.4315, and this approximates to 1.8519. So this is also 4 decimal places. If I evaluate that integral from 0 to pi sine of x out of x with respect to x using a calculator, I get 1.8519. So I can see that the 3 out of 8 rule approximates this integral better than the third rule of Simpson. Because when you look at the other one for Simpson, it is 1.8518. For this one, it is 1.8519, which is close, or which is almost the same as when we use our calculator. This is from. Thank you so much.